Hi, happy Friday. So, we're going to talk about another kind of transformation today called dilations. And it says, answer the following complete sentences on your bell ringer sheet. Actually, complete sentences. Um, so, A, Hippo A and Hippo B are transformations of the original hippo. Which one do you think is a dilation? And explain your reasoning. Number 2, do you think the dilation has a scale factor of 2? Or do you think it's more likely that it's 1/2? Explain your reasoning. To go from the original to one of these two, whichever one you think is the dilation, either A or B, to go from the original to A or B, which would you think would be more likely to be the scale factor? All right. Let's talk about this. Polygon Q is a scaled copy of polygon P. The value of X is 6. What do you think the value of Y is? What do you think the scale factor is? Some of you guys might be able to do this pretty quickly, and some of us need to think a little bit, which is totally fair. So think. And here's how I'm going to do it. I'm going to say, okay, there's lots of different ways you can set this up, but I'm going to set up a proportion. From Q to P, that top side is 3 divided by 4, and that's got to equal, I don't know what, for Y over 6. Then, I don't know if you guys remember this from a long time ago, but setting up proportions and solving, you cross multiply and divide is the way that I've been taught how to do it. So I would do 3 times 6 equals Y times 4. Actually, I would not do it that way, but you could. Equals Y times 4, and then divide both sides by 4 to figure out what that is. We go to Desmos. We go 3 times 6 divided by 4. 3 times 6 divided by 4 is 4.5. 4.5. So Y equals 4.5. And then it says, what is the scale factor? Well, the scale factor is, what do you guys think the scale factor is? We'll put it that way. I think it's, sorry, that's not the right thing. The scale factor is, if Q is the new one, it's going to be smaller than the original, right? So the scale factor is going to be 3/4. Okay, so here's the deal. Quick notes. Similar figures. They're not congruent figures, right? Congruent figures have same shape and same size. Similar figures have the same shape but different sizes. All the sides, their lengths are either bigger or smaller, but have a consistent scale factor. And the easiest way to deal with the scale factor is to think one of the sides, the new sides, divided by that's the equivalent or the similar guy in the original one. Like we did a minute ago where it was 3/4. Ratios of sides between the figures stays the same. So if one pair of sides is 3/4 as big, the next pair of sides is going to be 3/4 as big. But what's interesting is the angle measures do not change. That's why angle, angle, angle on triangle stuff did not mean, if we knew that 3 angles were the same, it did not mean that the triangles were congruent. It would just mean that they are similar, which is what we're talking about now. Similar. Now when it comes to check your understanding, we're going to try a few of these problems together. You're getting ready to move into a new house. The lengths of the walls of your room will be 10 by 12 feet. So we'll assume it's a rectangular room. 10 by 12 feet. When you look at the blueprint, the lengths of the walls on the drawing are, much smaller. 7.5 inches by 9 inches. Oh, and I better go back and label these. This is feet. That looks terrible. That's okay. That's feet. 10 feet, 12 feet, 7.5 inches, and 9.5 or 9 inches. What is the scale used on the blueprint? All right, so to find the scale factor, we just do one of the sides, new divided by the original. So you pick a side what you want, but oh, we got to be careful. This is feet, this is inches. We better do some converting. It's a lot easier to convert feet into inches. Then we get big numbers, which is fine. So how many inches are in a foot? 12. So 12 inches times 12 feet, which equals 144 inches. That's kind of hard to see. Let me try that again. Yeah, we'll just do this. 144 inches. And 10 feet, 10 times 12 inches is 120 inches. So when we are comparing our scale, we want to keep it all in the same units. So this is the easiest way to do this. Just go, okay, new divided by original. All right, 9. You get to pick which side you care about. Could be the long one, could be the short side. It's up to you. I'm just going to grab the one without a fraction in it. So new side is 9 inches divided by the original one, which is 144 inches. And then we're always going to try and simplify fractions, right? So your handy dandy scientific calculators have that fraction button that can do that for you. I don't have one of those handy with me. So I'm going to do, let's see, I know 3 goes into both of those, so I'm going to divide both those by 3 and see if that works. So 9 divided by 3, whoops. 9 divided by 3, it's okay. It's fine. Divided by 144 divided by 3. Oh, that didn't help me, right? That's the decimal. That's not what I want. Try it again. 9 divided by 3 is 3. 144 divided by 3 is 48. Oh, I think 3 goes into 48. So let me try this again. What about 9 divided by 9 and 144 divided by 9? There we go. So 1 over 16. 9 over 144 reduces to 1 over 16. So that's the scale, 1 over 16. And actually, we don't need to do the inches thing because it canceled out up there. All right, next one. Ellie creates unique cork coasters to sell on her Etsy shop. They come in 2 sizes, small and large. To make these coasters, she creates a template for the shape on her computer, then enlarges it to the bigger size. Find the missing dimensions. All right. First of all, we said these are similar shapes. What's going to happen with the angles? They don't change. So, X is going to be the same as that 124 degrees. All right, well that was easy. What else do we need to find? Need to find a side down here and a side over here. Okay, well let's figure out what the scale factor is. So she enlarges it. So this is the new 19.5 and this is the old. All right, so let's figure out the scale factor. Scale factor new divided by original. So in this case, that's going to be 19.5 divided by 13. Oh, that doesn't look like a 13. It looks like a B. Sorry. That's a 13. All right, so I'm just going to go over the decimals and calculator of any sort and do 19.5 divided by 13. And my scale factor is 1.5. Bada bing, bada boom. So there's my scale factor. Going from the small to the big, I just multiply by 1.5. So if I'm going to go from this side, the small to the big, I'm going to multiply by 1.5. So again, grab my calculator. I do 4.5 times 1.5. We get that is 6.5. No, that's taking too long. So 4.5 times 1.5 equals, what was it again? 6.75. So that's what this guy is over here. Okay, but now we need to go backwards because we're looking for this bottom length on the smaller one. So instead of multiplying by 1.5, we're going to divide. So we're going to do 14.25 divided by 1.5. $14.25 divided by 1.5. 14.25 divided by 1.5, and we got 9.5. So that guy is 9.5. Ta-da! We did it. Everything else is in there. We got all the sides and the angle that they gave us. Oh, I have one more side I need to do here, I guess. Alright, so to find this side, we're going from the small to the bigger. Are we going to multiply or divide? We're going to multiply by our scale factor. So we get 6.45. Standard Coke can has, I love Coke Zero, diameter of 6.25. So that'd be 6.25 across the circle top and a height of 12.25 centimeters. Whoa. Sorry about that. 12.25 centimeters. Coca-Cola is considering launching a Coca-Cola mini can with a diameter of 4. Oh, little baby. Centimeters. Okay, so the good news is we don't have to change units. It's all in centimeters. What would be the new height of the new can if the two cans are similar? So if they keep the same ratio. Okay, well let's figure out what the ratio is. Let's do new divided by original. There's more than one way to do this, but if we keep in mind the scale factor, this is kind of nice. So we could do 4 divided by 6.25, and this will tell us the scale factor. And that is 0.64. So that's my scale factor. So to go from the big guy to the little guy, I multiply by that scale factor. So that's what I'm going to do down here. 12.25 times my scale factor. .84. Alright, so that's how tall it should be. It should be 7.84 centimeters tall. Ta-da!